Okay, so let's get started with the do now. Alright, so let's have X, Y, and Z. And let's have two vectors. Let's call it vector W. And let's call it vector V. Alright, and let's create a parallelogram. Alright. Let's create a parallelogram.
Okay.
Alright, so let's find the area. Let's say the area, I'll just give you area. Area, let's say area is 2.5. Area is how much?
2.5.
2.5.
Well, I didn't go this far into linear algebra.
Okay, so now the cross product of, we call it V. So cross product of W times V is, let's say, K. And now let's draw the K.
Well, by doing this way around.
Let's draw the K. So let's make the K red. Okay, let's draw the K. One thing you know that K is the perpendicular to W and K is the perpendicular with
V.
Alright, so what I want you to do is the do now. Find the magnitude of K. Alright, I'm going to give you a few seconds, alright? And I want you to first try yourself on the little board you have. And then you come to the board and do it for the whole class. Now, raise hand who want to do it on the board.
Me.
Okay, so why don't you try first? And why don't then you do next? Go ahead.
This was really unsuspected. Just a tradition for me to just call myself. So, I don't know, 5? Because 2.5 times 2 is 5, right?
Let me see. So it's a square, so I think the area is just 2.5 square.
Okay, so
Thank you.
alright, so
6.25.
so good try, but both of you wrong. So this should be 2.5.
What?
2.5. So this is K.
What?
So this is 2.5.
Wait, what?
Alright, so we're gonna see the application of this cross product in the lesson. Okay, so let's get started.
Oh.
Let's get started. Okay, so we're gonna start with the Flux.
Excuse me, can you pass the class eraser to me?
Yeah. Alright, so let's start with the lesson. Alright, let's start with the lesson. Alright, now Flux. What is the definition of Flux?
AB cosine something.
B perpendicular A. I want you to write it down in terms of. I want you to write it down in terms of trigonometry. Now go, come to the board and write it down in terms of trigonometry.
Oh.
Okay, who want to try?
Okay.
Okay, go try. Write it in terms of trigonometry.
What I think is perpendicular means cosine 90.
Okay, let's go. Alright, that's probably correct, but we just don't want to specify the angle. We're just going to write what?
Cosine.
B, A,
40.
cosine?
40.
Cosine theta. Why should we write any angle?
That's
Just
not
theta.
how you write it.
And theta can be anything. Theta can be 0 degree to
100.
100 or 90 or 180 or it could be anything. So this is the magnetic flux. Now, what is magnetic flux? Magnetic flux is, what is magnetic flux?
B
The magnetic field,
BA cosine
times the
theta.
area.
That's how I remember it.
So the
BA
flux is
cosine
proportional
theta.
to magnetic field
Area.
Area
through the area.
through the area.
Passing through the,
Area.
what does that mean? Do you even understand what that means?
Not really. I just memorized.
Okay, so let's demonstrate what is flux mean. So what is this?
Two protractors.
Okay.
Ooh.
Can you create something using two protractors?
I mean a circle.
All right. Let's see whether I can create something.
Oh, a scissor?
So I'm gonna
What
cut
are you
it.
trying to do? Cut plastic in half?
Yeah.
And it surprisingly works.
Half circle, and then this one would be half
Half circle.
circle. Now why don't you come over here? Both of you come over
You
here.
can make a full circle.
Yeah, come over here. Yeah. Both of you come over here. So you over here, and you over there. Over there. Hold it. Hold it like that.
Due to the sharp edges
So
of
hold
the
it.
protractors, I would probably think that this is slightly dangerous.
Just hold it. It's not gonna bite you. I guarantee you. Okay? Hold it like that.
How does protractors bite humans?
Okay.
For one, they're not even alive.
Wow.
Hold on, hold on, hold on. Okay.
We just want to put like strong things
Uh,
on it so the plastic doesn't snap in half.
Okay. Pay attention to the things that I want to do. So the protector turns to what?
Circle.
Protector turns to circle. Now what can you do with this circle?
That's
Alright, now
very
stay over here and the whole class please pay attention. Can you imagine it's raining? Can you imagine that?
Yeah.
Yeah.
You can imagine it's raining, right? Alright, so why you don't hold it? You hold it. Yeah, let him hold it. So if it's raining, right?
Yeah. And
If you hold it like that, how much rain can go through this, let's call it flux? How much rain can go through?
oh, only the area inside this little hole. Only the area.
Good, now you're talking about area.
Oh, I see.
Can you imagine rain as magnetic field?
Okay.
Good. Now, if you hold it like that, Now, no, he gonna explain, you're gonna hold. How much rain can go through this flux, you think? More than before or less than before?
I think less than before because rain drips this way. So the rain would rain doesn't drip this way. So nothing would go in here and it would rather just bounce off. So none of it would go if it was sideways.
So that is correct. Now that is correct. Now this is the concept of flux. But concept of change of flux is a little different because the flux, this is the maximum, right? This is the maximum what?
Rain it can take.
Rain it can take. This is the minimum rain
It
can take, or maybe 0. But change of flux means this is the max because you can change the flux in a
very quickly.
All right. Okay, now we're gonna explain this in terms of trigonometry. Okay, we're gonna explain this in terms of trigonometry. All right, now I want you to go back. I'm gonna call you again.
So I have an idea. So
I'm gonna call you again. Okay, I really wanna know your idea, but can you hold your idea? Okay. Now,
why are you putting that around your sleeve like it's a bracelet?
okay, I'm just gonna ignore that. So this is theta and this is flux. This is theta, this is changing flux. And this is what? What are we gonna call? EMF.
Electromagnetic force.
Now,
And theta?
now we said that.
What about theta?
Theta, here. We said that for flux, this is what? This is
symbol.
This is
The max.
max, right? So the max
Maybe
represents.
close to max. We aren't perfect at determining it.
So max represent what? By what degree?
90.
90.
Pi over 2, right?
Pi over 2.
Oh.
Okay. And the derivative. Oh, let's not talk about the derivative.
Being perpendicular to the rain will get you the most rain through the hoop.
That's right. So this is you're gonna get to write it.
So that's why cosine 90 is cosine 90 is 0 though. So I know that.
Oh no,
Yeah.
this is not correct.
Is that? I recognize all of
yeah,
the trigonometry.
Okay, now I want you to write down the name of this function. Y equal to what? Y equal to what? And Y equal to what? Go ahead and write it down on the board.
Okay.
Okay, I have a huge idea. So, I remember this from early trigonometry.
Just write it.
Really? I can't tell stories. Well.
Okay, no, other guy.
Oh.
He already wrote it?
Okay.
Okay.
Oh, no, I have an idea.
Alright, thank you. Go back to your seat.
I'm pretty sure it's secant theta.
Secant theta?
Okay.
Alright. I know how dumb you are, so don't confuse that with secant theta.
Okay, now. Alright, now you understand the flux now.
Yeah.
I'm gonna give you more understanding tomorrow. So you get to understand flux, right?
Yes.
Rain as a magnetic field and this as a flux, and the orientation of this, the magnitude of flux depend on the how you orient this one with respect to
that's my
rain.
idea.
falling rain.
Yeah,
Okay.
that's my idea. So if you do it perpendicular to the rain, then
Okay.
the rain will all fall through. But if you do it with the side of the rain,
Good.
none of the rain will.
Now let's talk about the EMF. EMF is proportional to what?
So that's why
num-
photon data here.
Change in
Proportional to
something.
change in?
Flux?
No, not change in flux. It's proportional to rate of.
Oh.
Rate of change in
Flux.
flux passing through
Passing through
Wire.
wire. And the wire
area A.
Area A. And the area A in this case is like the hoop you just gave me.
How can you write that then? EMF is?
EMF.
EMF can be written as just epsilon. So EMF is rate of change of flux. So that means rate of change of flux.
Over
This,
change
right?
in time.
Now, what if you have a loop, more than one wire?
Oh.
So then
multiply them by
multiply that by
number of loops.
n.
Yeah, because then the amount of rain you can get is multiplied because you go through many more hoops. So that's much more rain through a single surface.
Alright, now we're gonna write the final version of the equation.
So if we have
EMF.
like 600 protractors, then we would like make a swirly like past the rope that would be like a multiple rope thing.
Good.
And that
So
means
negative n delta over t.
Oh,
What is
negative.
this negative thing?
Negative is the what? Direction of induced
Current.
EMF. Direction of, well, there is a difference between EMF and current. EMF is the voltage and current is a byproduct of voltage.
Oh.
So this is the direction of what? Induced
Current.
EMF.
EMF.
Now, what is the then difference? Okay, since you mix it up, what is the difference between voltage and EMF?
Well,
EMF.
it's like a pseudo voltage.
It's kind of induced voltage, right?
Yes, it's induced.
This is induced voltage.
Yeah.
How
it's
can
an
you
induced voltage
How can you
and-
create this?
By
It's by
moving
magnetism.
moving
You
By
have
moving
the-
a magnet.
You have the loop
and the moving
and you have a magnet.
And then you just stick the magnet through the loop and start moving.
You move the magnet with velocity v through the
wire.
wire and you create
EMF.
EMF, and EMF can create
Voltage.
I wish we had a copper
what?
swirl.
EMF is the voltage. EMF can move the charges and then charge can create induced
Current.
current.
I wish we had a copper swirl so we could demonstrate the two currents.
Now listen to this one, voltage. How can you create voltage? EMF, that's how you create EMF. How can you create voltage?
Potential difference.
Potential difference between two terminals. For example, you take a lemon, you put a nail, you put a
A penny. I see where this is going. This is a lemon battery.
lemon battery. That's how you can create the voltage.
I did those when I was 2.
Yes. Can you light up a bulb by voltage?
Yeah.
Can you light up a bulb by induced EMF?
Yes.
Yes. But
Because induced voltage induced current.
Who
which
created
makes-
that?
Volta.
Alessandro Volta. Who created this?
Or hands.
Orsted.
Or
Not Ørsted. Faraday. Michael?
Uh,
Faraday. So this is called Faraday's law of induction. Faraday's law of.
induction.
This is one of the most beautiful equations in physics. Faraday's law of induction.
Wow.
Negative N, which is the loop, delta flux, magnetic flux, over
Change in time.
change in time. Okay, what can we do with Faraday's law of induction? Can we light up a bulb? Well, we can do a whole lot of things. We can even create the computer hard drive
Wow.
by Faraday's law of induction. But that's not what we're gonna do. We're just gonna try to solve the problem
Okay.
for greater understanding. So
I
now,
don't want like too complicated stuff.
now-
Otherwise, after like lesson 40, we'd be building whole computers in front of you.
what is this?
It's going into the board.
What is this? I know it is going into the board, but what is this?
Magnetic field.
Magnetic field. Magnetic field has what? A magnitude, right?
Yeah.
So let's say magnitude is
One.
0.6 Tesla.
Okay.
Okay? What is the magnetic field right here?
0.
0 Tesla. What is the
Oh.
magnetic field right here?
0 Tesla.
0 Tesla.
Yeah.
Now,
So just the magnetic field. There's no magnetic fields anywhere else.
you have, what can you have?
A bar? Maybe?
Square or something.
A square?
Okay,
What?
you have a square loop.
Uh-huh.
Alright, let's say 5 centimeter.
Oh, yeah, sure.
If this is 5 centimeter, what is this?
Also 5 centimeters.
5 centimeter. A square loop moving with the velocity b to the
Right.
Right.
right. This magnetic field and this system has a resistance 100
Ohms.
ohms, and it takes 0.10 seconds for the square to for the loop of the square to move.
Wait, I have a question. So you mentioned multiple like hoops, like these hoops. So how many like hoops are there?
Good.
in-
And let's say n is equal to 100. Good point. N is equal to
100.
100. I love 100.
Yeah, such a beautiful number.
It's just a beautiful number. I agree. Okay, now what can we do? Let's first find the flux.
So
Okay.
convenient.
Let's first find
The flux.
the flux. Okay, let's go find flux.
So
What is the flux?
So
BA
cosine theta.
cosine theta. And since theta is 0 degree, we can drop the cosine theta.
the
So B is how much?
0.6 Tesla.
0.6. A is how much?
0.5 square.
0.5 square.
Or 0.05 square. Sorry.
Or 0.05 square, because divide by 100,
Yeah.
you get 0.05
5.
meters.
so 0.0025. So I can do that.
Zero.
I
0.6
got
times
0.0015.
it's 0.0. Yeah,
15 what?
0.0015
Weber.
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 Yeah.
Oh yeah, Tesla meter squared. Webers.
Tesla meter square, Weber. Okay.
Was that like Professor Weber's like thing from Einstein?
Sure. Magnetic change of magnetic flux. What is change of magnetic flux? Do you think it takes time for magnetic flux to change?
Yeah.
Of course.
In 10 seconds. In
10 seconds.
0.10 seconds. Is equal to what?
10 and 10 are very different.
0.0015.
Is equal to negative.
Oh.
Oh.
Negative. Why? Because final minus
Initial.
initial. The final would be 0 and initial would be this one.
Oh,
So
okay.
0 minus 0.0015. So what is it? Negative
Negative.
0.0015
Weber.
Number 3. What can we find?
Maybe EMF.
EMF. So let's find EMF. EMF, I told you what? Negative and change of
Over time.
flux over time. N is how much?
100.
100. Don't forget negative. Change of flux is how much?
Minus 0.0015.
Minus 0.0015 divided by
0.10.
0.10, and that gives you how much?
Wait, I can do it. So that's
I got 1.5.
Yeah, 0.15 divided by times 10. It's 1.5. I actually did that in my head. I am big.
1.5 what?
Volts?
Volt. 1.5
Because
volt.
it's induced to voltage.
Because it's the same
Yeah,
thing.
it's the same thing as okay. Now,
No, it's induced.
now since we have voltage, can you measure the current?
Alright.
That's the big deal. I mean, it
Yeah.
creates the induced current. So we want to measure the current.
And we have resistance.
The current is VIR. VIR.
V over R.
So V over R. So that EMF over R. So what is EMF?
1.5 volts,
1.5 watt over
100 ohms.
100 ohms.
Yeah.
And that is how much?
0.015 amps.
0.015
Amps.
amps. Alright, now let's find what?
Maybe E for energy.
Energy. Let's find the energy. Energy is equal to, I don't know, I squared RT.
Oh.
I squared RT. From Ohm's law. From Ohm's law, right?
Yeah.
Is that right? Because W is PT, right?
W work is
Work is PT, right?
T.
Work is PT. And then P is what? IR. P is BI.
P is
P is BI, right?
right.
So VIT. And then,
Oh.
and then,
I R.
I R.
So
Can we-
it's I squared R.
so V is IR, right?
Yeah.
So I, R, I, T.
So,
So
I
I
square
square
RT.
Okay, good.
Irrit.
Very nice. Very sweet.
Hey.
So I squared is how much?
What is
Well, 0.015 squared.
0.015 squared.
what is 0.00225?
R is how much?
100.
100. And T is?
0.10.
So what is that?
0.0023.
0.0023. What?
Joules.
Now we can find the force, right?
Yeah.
So 5,
Because force
6,
is
force.
Oh,
Force
I
is
would like to come in and say that it's actually 0.00225.
2 to 5. Okay, that's fine. 2 to 5.
It was in overestimated in your lesson notes.
W over D, right?
W over.
What is W?
So,
Oh, what
Point
is FD?
0.0225 joule over D is how much?
5
But we don't know.
centimeters.
0.05.
Oh,
And how much is that?
so 0.46 newtons?
0.46 Newton. Good.
I'm just guessing.
You don't have calculator? Please don't guess. Please make sure you check the math.
Yeah, we
Okay.
got it all.
Seems about right. I checked.
All right, so let's do the
Oh
exercise.
yeah, another attack. Oh no, it's not it. Yeah,
So-
it's 0.45.
Okay, so let's do the exercise, okay?
Another maybe like I don't know correction overestimate
Yeah, sure.
0.45 instead of 0.46.
Okay, so the exit slip would be, I don't know, what should be the exit slip, you think?
Maybe sine,
I'm not as
cosine.
smart as you.
I remember something about sine.
No
and
exit
cosine.
slip today. Okay, bye everyone. See you tomorrow.